So another topic alongside probabilities and mean, median, mode is the topic of standard deviation and variance. Okay, overall, standard deviation is often represented like this, and it basically implies or has an implied meaning of a spread. It's a measure of spread from the overall mean of the data set. Okay? So it's a measure of spread from the mean or central tendency of your data set. Now, the variance is just how the data varies from each point to point. Okay. Another word for another definition of variance is that it is a state of being variable or different. It is also the number of degrees of freedom for a physical system. It could also be the square of the standard deviation. Okay, so it's also known as the square of all the deviations from each element. Okay, so if I want to find the actual square of the deviation, I have to actually subtract the mean from each one. So another formula often used for variance is it's the sum of all of the elements where each element has the average subtracted out from it, and it's squared. And then at the end, I add them all up, which is what that sigma means, and then I divide by the number of n times I do that, okay? So the cool thing about this is that it actually helps us create the standard deviation, because what this will give is the variance. Okay, now the standard deviation is always the variance square rooted. So, for example, if I have the variance, then I know this implies the standard deviation is equal to the square root of the variance. But I have to calculate that variance first. So on the page where you've got all of your data points, okay, let's talk about first what kind of distributions they have. But basically in statistics, we use distributions to represent relationships, okay? So the one that you will probably talk about is called the normal distribution. You have Poisson, you have geometric, you have hypergeometric, binomial. You have a bunch of distributions, but by far this is probably one of the most important topics in stats, because the normal distribution fits huge data sets. Now, when you draw the normal distribution, basically what it says is that between 0 and 1, I have a mean right here, which is the x-bar. And I know that no matter what, the mean will be at the top of the curve between 0 and 1. Now, this is what we call the mean, or the average, also known as mu. Now, this is a bell-shaped curve, and it represents the normal distribution. Now, from the mean down there, between the probability of 0 and 1, now, if it's 0%, it's not likely. It's impossible. If it's 1, it's completely possible. So when we talk about this, we talk about probabilities or percentages or ratios. Now, let's talk about rubber bands. So in example 1, we want to find out how consistently rubber bands will travel when launched. So you use a ruler to launch 2 rubber bands 7 times each. You generate the following data sets. Okay, we know rubber band number 1, and I'll just do RB number 1. And I generate centimeter lengths of 182, 186, 182 again, 184, 185, 184, and 185 again. Rubber band number 2 gives centimeter lengths of 152, 194, 166, 216, 200, and 176, and 184. That's the last part. Now, if I wanted to create some frequency diagrams, I could. We call these dot plots. Okay. Now, a dot plot basically measures the overall frequency and the number of times, or the distances, right? So the frequency as it happens. Okay, so I'm going to put frequency, and I'm going to put number 1 for rubber band number 1, and then I'm going to do the second one, and I'm going to do the number 2 frequency, or how many times it exists. Okay, now, this would be a rubber band number 2 distance. And this is going to be rubber band number 1 distance. Now, we're just going to create this little lightning bar to represent that, you know, some things occur between 0 and whatever the number is. Okay, so we're going to start with 180 on rubber band number 1. And each tick mark is going to be worth 1 point. So 181, 182, 183, 184, 185. And we'll do 186, 187, 188, 189, 190. Okay? So do I have any 180s in this set? The obvious answer is no, but I do have one 182. Okay? So I've got one 182. Okay, I've got 2, so it occurs a second time. Does it occur any more times? No. Do I have any 183s in there? No. Do I have 184s? Yes. How many? Well, I've got 1, 2, so I have 2 again. Now, do I have 185s? Yes, I have 1 and 2 again. Okay. Do I have any 186s? Yes, I have 1. Okay, so that would be a dot plot of the rubber band number 1. Let's talk about rubber band number 2. We're going to do sets of 10s here. So I've got 150, 160, 170, 180, 190, 200, 210, and then lastly 220. Now, do I have anything between 150 and 160? Yeah, I've got 152. So I've got 1 at 152. Do I have anything after between 160 and 170? Yeah, I've got 166. So probably right there. Okay. Do I have anything between 170 and 180? Yeah, I've got 176. So something right there. And it occurs 1 time. Do I have anything between 180 and 190? I've got 184, so about right there. Do I have something between 190 and 200? Well, I've got 194, so 194. Do I have something at 200? Yeah, obviously. Do I have something at 216? So between 210 and 220, 216 occurs 1 time. Okay. Now, the mean here, for both of them, the mean, if we added them all up, it gives me the same amount on both of them. But if you notice, the spread is different. So here the mean is 184 centimeters. Once again, the mean here is also 184 centimeters. But if you look at the overall spread, the spread is a little bit different here, okay? Whereas the spread's just a straight line, if I were to create a bunch of squares, okay, with this, then obviously, or rectangles, obviously, this doesn't really give me a bunch of things, okay? Matter of fact, it actually is not very spread out, okay? So it's very thin, and then I've got blank spaces in between there. But, you know, I can create several things that will happen that will work out to be that. But it's just not going to be very productive on this one because I've got stuff that just is not very spread out. There's no variability here. They're all about the same height. Here, there's more variability, right? So the variability is greater because it's more spread out. So variability high, and then the variability here would be low. Okay, so it's not very variable. It's not diverse enough to actually extrapolate some kind of meaning or explanation to fit the relationship. Okay, so that's a little topic about variance. Okay, it's just basically the overall spread between one data set to the next data set, to the next data, to the next data point. Okay, and each data point has an actual value. Now, statistics is very good at analyzing quantitative and qualitative relationships, because in life, not everything's a function. A lot of things are actually relationships. So when we talk about the normal distribution, we need to talk about variance. We also have to talk about the standard deviation, or the overall measure of the variance. Now, a little topic about that. Normal distributions allow us to calculate standard deviations. Okay, so if I were to take that same data set for the rubber bands, okay, and I wanted to use just rubber band number 1, okay, if I wanted to calculate the variance, I have my data element, okay, the data point, or the element. I have one that had garnered 182, one was 186, one was 182, one was 184, another one was 185, another one was 184, and then another one was 185, okay? To find the deviation from the mean, okay? So the deviation from the mean, I'm basically just going to subtract the mean from each data point and basically square it. The deviation from mean squared, okay? Now what this will do is I'll take 182, subtract out the mean, and square it. Well, we know that the average was 184, so we know that the x bar is 184. Okay, so 182 minus 184, and then I square it. 182, that was 186, so 182 minus 184 again, square it. 184 minus 184, square it. 185 minus 184, square it. 184 minus 184, square it. 185 minus 184, square it. Now, 182 minus 184 was negative 2 squared. 186 minus 184 was 2 squared. 182 minus 184 was negative 2 squared again. And then I had 0 squared, and then 1 squared. And then once again I have a 0 squared, and then on this one I have 1 squared again. Now if I keep going, I'm going to get 4 here, and then I'm going to get 4, 4, 0, 1, 0, 1. Now I have to add them all up, okay? So basically I'm going to take all of these elements, okay, and I'm going to add up all the elements that I subtracted the mean from, square it, and let's just do it n times and divide it by the number of times I have it. Well, I have 1, 2, 3, 4, 5, 6, 7 elements. So the overall average is the sum of all of these numbers right here, which we get 4 plus 4 plus 4 plus 0 plus 1 plus 0 plus 1 divided by 7. In this case, and this is going to be the overall variance. Okay, in this case I get 4 plus 4 plus 4 is 12, plus 1 is 13, plus another 1 is 14. So I get 14 divided by 7, which is 2. Okay, now the standard deviation, is equal to the variance square rooted. So the square root of the variance, which in this case would be the square root of 2, which is approximately 1.4142. 1.4142. Just round it up, okay? So here's 10 thousandths. Now, with that being said, that means I have a standard deviation, one standard deviation from the mean. So I know the mean is 184. Now, remember how in the previous example we used a bell curve for the normal distribution. So what I'm going to do is explain what standard deviation actually does right here. Okay, so if we remember correctly, we had the mean, which was x bar. Okay, and then we have the mean again, which is x bar. Okay, now the mean that we said it was is normally the central pole for the tendency for normal distributions. Now, anything that falls within a standard deviation, one standard deviation is the length it takes to get to the next data point, plus or minus the standard deviation. Now, another symbol for standard deviation is rho. So this distance right here is the standard deviation away from the mean. If I go 2 over, it is 2 standard deviations, so plus 2 rho. This one's just plus a rho. Now, if I go away from the mean and I want to go below the mean, so if I go away from the mean and I just do it 1, this is minus a standard deviation. All the standard deviation is the distance from this point to the next point, okay, in terms of variability. Now, for us, we said that our variance here was right here. So if I know the mean is 184 centimeters, then I know I'm going to add one standard deviation. Well, that one standard deviation would be right here. And so I know one standard deviation plus a rho away from the mean, would basically be 184 or 185.4142, approximately. I was going to put 184 plus the square root of 2. Now, if I want to do that twice, I'm just going to add in another point. If I do it twice, I'm right here. Well, 185.4142 plus another 1.4142 would basically be 186.8284. Now, that's all standard deviation really is.